All right, so as I said earlier, we're going to look at analytical geometry, and because we've started late tonight, will not take a lot of time, will not take 2 hours, but it will just be 45 minutes or just 30 minutes. Yeah, so the first thing that we're going to look at is a circle. So first look at a circle. Okay. So we'll first look at a circle. Then from a circle, we'll move to an ellipse. Yeah, so I'm sure most of us here, we know the definition of a circle. So if you don't know it, you can try to search on Google, but it's just a set of points which are equidistant from a given point, or a center in short. Okay. So the general formula for a circle is given by this, where the center is just h, comma, k. Yeah, so I don't know why it's writing like this. Okay. Okay, so the given, the general formula for a circle is just x minus h squared plus y minus k squared is equal to r squared. And then the center is just given by equating what is there, what is in the brackets to 0. So when you equate x, when you equate x minus h to 0, the x coordinate at the center of this circle will just be x is equal to h. And then the y coordinate, you get it by equating y minus k to 0. And then when you equate this to 0, you get the y coordinate by making y the subject there. So this would be k. So in other words, we are saying the center of this circle here is simply just h, comma, k. Yeah, so this is the center. And then the radius of this circle given by this general formula here is simply just r. So how do you get r squared? Whatever that you have this side, you just equate it. Okay, we're going to look at examples. If for instance you have 9 this side, just equate that 9 to r squared, and then you find the value of r. So the value of r in this case will just be plus or minus 3. That is the square root of 9. But we know that the radius is always just positive. Yeah, it's never negative. So we just get the positive r, which is r is equal to positive 3. That's all. Okay, so let's quickly move on. So this is what I was just talking about. The center of that circle will just be h comma k. Yeah. All right, so that's what I was just explaining there. So the other thing we're going to look at, okay, let's just look at some examples. So the way they bring these questions, so you guys, I don't know if they are going to teach you a circle, because I believe it's very simple. They consider it to be simple, so they don't teach. So the way they ask these questions, sometimes they would ask you to say, sometimes they would ask you to find the center, the radius, and also to sketch the circles. And some lecturers will just say, describe the following conic sections, or describe the following circles, or describe the following geometries. Yeah, so that's how they ask these questions. So if they say describe this geometry here, first of all, you need to identify that this is a circle. You need to know the general formula of a circle. So when you have a minus in the two, sorry, a plus here, just know that it's a circle. I'm going to explain if you have, what happens if you have the minus there. Okay, it's also another thing. So in this case, so if you've been given such a geometry to describe, you first have to look at your center. So what is our center? So this geometry here, or this equation, can also be written as, so we can write this equation as x. We write this equation as x minus 0, and then in brackets, then we say this is squared, and then our plus there. Then we also say y minus as 0 in brackets, and then squared is equal to 25. This is how we can write this equation. And then from there, we can now see that our center is 0, 0. When you equate x minus 0 to 0, simply just get the value of x to be 0. Then there you also just get the value of y to be 0. Hence the center of this circle. Okay. So the center of this circle C is just 0, 0. So this is going to be our center. And then how do you find the radius? The radius, I said, you just equate whatever that is this side to r squared. So you say r squared is equal to 25. I don't know why it's doing this. Okay. Okay, so the radius is just 25. Okay. So the radius is just 25. So you equate to find the radius, you just equate 25 to r squared. Then from there, you find the square root of 25, meaning you square root both sides to get rid of this square. So you're going to have your value of r to be equal to 5. So if you want to sketch this circle, this will just be something like this. That's going to be, we draw a straight line there, and then also there. Then you have a 0 there. So that is our center. Then this side we have, so we have that, So this is our x-axis, and then that is our y-axis. And then we know that our center is 0, 0, which is just the same point there. And then the other thing we have is the radius. So we have 5 units going to the right, 5 units going to the left, and then also 5 units going up and 5 units going down. So you have something like this. You have 1, 2, 3, 4, 5. You have 1, 2, 3, 4, 5. Also have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So here we're sketching, we're not drawing, we're sketching. So if you've been told to sketch, simply just have to approximate. You don't have to draw the actual thing. Okay. So this I'm sure will not even come out the way it's supposed to come out. Okay. But it's a circle with radius 5. Okay. So that's how you sketch. All right. So let's move on to the next question. I don't know if you guys have a question on this one before we proceed to the next question. Okay. Let's move on to the next question. All right. So the next question is
So
okay.
So yeah, Harmtedy, I joined in like a little bit late. I didn't see the general formula for circles.
All right.
The general formula you're talking about.
Okay, the general formula for circles is this one here. Okay. So if you have a book, you can write it somewhere. So that even as
and I've got a question.
Okay.
All right, thank you.
Yeah, I've got a question, Mr. Harmtedy.
Okay.
Yeah, you said the way when you have a positive sign, you have to know that it's a circle. What if you have a negative sign in between the equation?
In between the equation, it means something else. It's not a circle.
Okay.
Yeah. All right. So let's move on. Okay, so we have this other question here. Says we describe this question. We describe this function there. So we are going to do the same things we did here. So in this case, we don't have to include my zeros. What we just need is to equate what is in the brackets to 0. So we're going to say x minus 2. When we equate this to 0, we're going to get the value of x to be 2. And then when you equate y plus 3 to 0, you are going to get the value of y to be equal to 3. And then, sorry, negative 3. So we're going to get the value of y to be negative 3. And then to find the radius of this given circle, we just simply say r squared is equal to 9. And then from there, we find our r to be 3. Okay. So from there, we find our r to be 3. Then let's now sketch the curve. Sorry, the geometry. We're going to have something like this. We have our center to be, so you get the center from these same values, 2, negative 3. 2, negative 3. So we're going to have something like this. Our center will be, our origin. So the origin is there. And then we're going to move 3 steps going to the right. 2 steps going to the right in the x. We're going to move 2 steps in the x, which is 1, 2. So we have 1 there, and then we have 2 there. Then we're going to move 3 steps going to the negative y. 1, 2, 3. So this is where our negative 3 is. So our center of this circle is just simply at this point. Okay. So from there, let us now sketch this circle. So let's look at the radius here. So the radius is 3. So meaning we have 1 point. Our first point is going to be somewhere there. Yeah, because our radius is 3, meaning, is someone with a question? Okay, it's not, there is someone with a question. Okay, so our radius is 3. So we're going to make 4 points, which will help us to sketch this circle. So the first point we are going to have is, we're going to move three steps going up. So we're going to say 1, then 2, and then 3. So we're going to have 1 point there. Then the other point to just move 3 steps going down, because that's our radius, which is here. So move 3 steps going down, which is 1, 2, 3. So I have another point somewhere there. Then the other point we're going to have is moving 3 steps going to the right and 3 steps going to the left. So we're going to have 1, 2, 3. So we're going to have another point somewhere there. Okay. Then we'll also move 3 steps going to the left. We're going to have 1, 2, 3 on negative 1. We're going to have somewhere there. So which is, yeah, so these 3 points that we have made are the ones that we're going to use to sketch our geometry. So this is a circle to be something like this. We're just sketching, not drawing the actual thing. Okay. Yeah, so that's our circle. I don't know if you guys have any questions about this, or we proceed. Okay, so silence means that we've understood. So let's look at the next question. So it's not always that you're going to have a straightforward question like this one or this one. Sometimes they will give you something like this. And the way it is, all the 4, yeah, they're about 5, all the 5 geometries that we're going to discuss, they can be expressed in this format. So sometimes they'll just give you something like this, and then it's up to you now to know whether this is a circle, this is a parabola, this is an hyperbola, or this is a, what's this? Or this is an ellipse. Yeah. So it's up to you to know. And how do you know? you have to go back to completing the square method, to that method called completing the square. So we're going to complete the square of this equation here. And then after completing the square, then it will tell us to say this is a circle. Then from there we get our centers and the radius. Okay, so let's quickly begin. Let's complete the square of this circle. So the first thing that we're supposed to do here, we make sure that x, we put together this x and that. Then the other thing is that we make sure that this y is together with that y, and then we'll take this -6 to the other side of the equal sign. So I'm going to write my x squared there. So x squared, then plus 6x, then we say plus y squared, then -2y there. Then we say this is equal to what? +6. So let's complete the square of this first part and that second part. So we'll be doing them simultaneously at the same time. So here we don't have anything to factor out this side. So what we do is just to find the half of 6x. So finding half of 6x, half of 6 is 3. So we're going to say x squared, then plus 3. Then we're going to square this. Then minus 3, we'll also square this. Then plus 6x. Then we move on to y. So even for y, we do the same. So we say y squared there. And then we say plus the half of -2 is -1 squared, then minus -1 squared again. Then we say minus 2y is equal to 0. Sorry, it's equal to 6. So it's supposed to be 6, not 0. Okay. So it's equal to 6. So from there, let's now finish the completing the square here. So we complete the square of this first part here. We're going to have x. So this is x, then plus 3. Then we put them in brackets, squared, then minus 3 squared is 9. Okay, so 3 squared is 9. That's the problem. Okay, 3 squared is 9. And then we forget about this. I'm sure you guys learned the completing, I'm sure you guys learned this method on quadratic functions. So we forget about 6x, move on to this. Then we're going to say, we're going to have plus, this will be y minus 1 in brackets, then squared, then minus -1 squared will just give us 1. Then we say this is equal to 6. So -9 and -1 will give us -10. So we have x plus 3, then in brackets, squared, then we're going to have plus y minus 1 squared, then this is -9, -1. This will give us -10. Then this is equal to 6. So we're going to have x. So this is x plus 3 squared. Then from there, we're going to say plus, then this part, write it there. This is y minus 1 squared as well. So this is going to be equal to 6 plus 10. So the final answer will be x plus 3 squared plus y minus 1 squared is equal to, so 6 plus 10 there will give us 16. So we can see now that this is in the format of a circle. So I think this one is straightforward. From here, I'm sure most of us can take it up because we just need to find the center So the center here will be, you equate this part to 0. So when you equate x plus 3 to 0, you get the value of x to be -3. Then when you equate y minus 1 to 0, you get the value of y to be +1. So meaning the center is just going to be -3, 1. And then the radius, like I said, you just equate r squared to 16. Then the value of r becomes 4. Then you sketch. I'm sure sketching is not a problem. This one, so our radius is 4, and then our center is -3, 1. So -3 meaning we're going this side 3 steps. So -3, then 1. So 1 there. So we're going to have our center somewhere there. Yeah, so I'm sure sketching is not a problem. Most of us can do the sketching. And after this, I'll give you an exercise. I'll give you an exercise immediately after this lesson. I'll give you an exercise because today we're just doing ellipse and the circle. So for the circle, we're done. So move on to the ellipse, and then I'll give you an exercise on both the ellipse and the circle. You have to submit tomorrow. Yeah. All right. So sketching, I'm sure, is not a problem for most of us. I think for all of us, I don't know if we have any challenges with sketching, or do we have someone who doesn't know how to sketch from what I've explained? Okay, so it seems like everyone has understood. All right, so this is how you deal with circles. Let's move on to the ellipse. So I'm sure most of us know what an ellipse is.
Relationship, ellipse.
Okay, an ellipse, it's a shape which looks like an egg, something like this. Okay. It's a shape which looks like an egg. It's normally like this, or can be in the X like that. It's a circle which is, I don't know if we can say a circle which has been sheared, something like that. Yeah. So it looks like this can either be in the Y or in the X. Okay, now let's look at it. We also have to know the general formula for the circle, the general formula for the ellipse. We need also to know the general formula for the parabola, the hyperbola, and a line. Yeah, so lines, I'm sure the reason why I've skipped the line, we all know lines are just normal things we've always been dealing with. Y is equal to x plus 2. This is a line. X squared plus, oh sorry, this is a parabola. Okay, so lines, we know them. Y is equal to 2x plus 3. All these are straight lines. Yeah, so let's just look at the ellipse, then we call it a day for, yeah, call it a day. So for today, we'll just do circles and ellipse. Okay, so this is the general formula for the ellipse, which is in the X. And then the general formula for the ellipse, which is in the Y, is this one. So I don't know if you guys have noticed the difference between these two, these two equations. So the difference here is the value of A. So when A is under X, then means that the ellipse will be in the X, to be something like this. And then if the value of A is in the Y, the ellipse will be like that. And then what you need to know is that this A, I'm sure you can see there's A there, there's also B there. So what you need to know is that A is always greater than B. So this is what you need to understand. When you find B being greater than A, just know that it's something else. It's not an ellipse, It's an hyperbola. Yeah. So we'll look at the hyperbolas the next time we're going to do mathematics. So when for the ones is for the ellipse, A is always greater than B. Yeah, so you should, or you can say A squared is always greater than B squared. It's just the same thing. So these are the general formulas. So this is what I was just explaining. Yeah, so don't worry about what you're seeing here, the H, K. These are just the centers. I'll show you how to deal with them. Yeah, so when describing an ellipse, for the circle, we're just finding the radius and the center for the circle. Yeah, that's so. But for this one, you also need to find the focus. Then apart from the focus, even the eccentricity. So you need to find these four. Yeah, not only these, you also need to find the vertices. Yeah, the vertices. Then for these, we have minors and majors. So when you talk about the major axis, sorry, you also need to find the axis, so the length of the axis. Yeah. So the length, hey, length, is this how you spell length? Okay, you know what I'm writing. So the length of the axis. So the length of the axis. So we have the major axis. The major axis is just the long axis, this one. Then the minor axis is this one. So I'll show you how to find all these. So if they tell you to describe an ellipse, you need to find all these 6 things. You find the radius, you find the center, you find the focus, the eccentricity, you find the vertices, you also find the length of the axis. Yeah. So the meeting here is telling me to say we're remaining with 10 minutes. So after 10 minutes, I'll send another link. I'll send another link so that we just summarize the ellipse. So let's begin. Let's look at an example. Yeah, so this is what I was just explaining. A squared is always supposed to be greater than B squared. And then, so this one here is an equation for this one. Then this one is an equation for that. So to find the length of the major axis, you just get the value of F from there. Then you multiply it by 2. So in other words, what they mean is that A is just the distance from this point to that point. So the distance from there to there gives you the value of A. And then, so if you want to find the distance from this point to this point here, means that you have to multiply this distance by 2. Same applies to the minor axis. So the minor axis, we're saying the value for the minor axis found by 2b. So 2b, if the length of the minor axis is found by multiplying b, by multiplying 2 by b, means that this distance from there to there is simply just b. Same applies to this distance from there to there. It's also just b. Then the distance from there to there is simply just a. Then same applies to this part. Okay. So let's quickly move on. Okay, so the eccentricity is found by saying C. You just, okay, eccentricity is given by E is equal to C over A. So I'm sure you're asking yourself, where can we get C? C is not the center. Don't look at this point here to say C is the center. No, it's not the center. So you find C C squared is using this formula here. So if I find C using this formula, C squared is equal to A squared minus B squared. I don't know why I forgot to write it. So this is how we find, oh, C. I thought I didn't write it. Yeah, so C squared is found by using this formula here, which is A squared minus B squared. So to find the eccentricity, you just say C divided by A. Okay. So let's look at these examples here. So the question says find the vertices and the foci. I don't know if you can go the foci, but focus, yeah, of the ellipse given by the equation. So this equation here, let's find the center. Let's also find the vertices and the focus of this equation. Let's start with this one. So the first thing you need to do when you've been given an ellipse to describe, you first have to find the values of A and B. And you can't find the value of A or B without identifying which one is your A and which one is your B. So our A here, we said A is always greater than B. So the biggest number is the one that we're going to get as A. So here we have 49. So A squared. So A squared is just going to be equal to 49, meaning the value of A becomes 7. And then B squared is just going to be the other number there, which is 25. So meaning the value of B becomes 5. The value of B becomes 5. Then from there we can now find, yeah, so after finding the value of B and A, we can also find C. Yeah, we can also find C. So C, we said, is given by, so C squared is equal to A squared minus B squared. So C squared is just going to be equal to, our A squared is 49 minus 25. So the value of C will just be, so 49 minus 25 gives us 24. So the value of C will just be the square root of 24. Yeah, so the square root of 24 can also be written as the square root of 4 times 6, which is just the square root of 2 root 6. Yeah, so this is 7 here. Okay. So from there now, I think we can sketch the ellipse. So the other thing you need to identify from this equation is this ellipse in the X or in the Y? How do you know that? You look at the value of A. So if A is under Y, in this case, our A is under Y here. It means that the ellipse is in the Y. And then if A is under X, it means that the ellipse is in the X. So in this case, our ellipse is in the Y. So we can sketch this ellipse. So that is our center for the XY plane. So the center for this ellipse is simply 0, 0, because we don't have anything there. Remember what we said? We said the general formula for the ellipse is this one here. And then in this case, the center is H, K. But in the question here, if you look at the question, we don't have anything there. We don't have H, we don't have K there. So our center for this one becomes 0, 0. So the center for this is simply 0, 0. And then what else? Okay, we have found the center. Yeah, so we found the center. Let us now find the vertices. So from these equations here that we've been given, our V1 here is found by adding A plus H. And then our V2, the other vertex, is found by subtracting A from H. I don't know if you're able to see what is written there. In other words, what we have here, where is our A? Our A is 7. So if our A is 7, it means that we're just going to move. We know that this ellipse is in there, is in the Y. So we're going to move 7 steps in the Y, going up and down from the center. So our center is 0. We're going to move 7 steps going up. 1, 2, 3, 4, 5, 6, 7. We also move 7 steps going down. 1, 2, 3, 4, 5, 6, 7. And then we also move 5 steps in the minor axis, which is represented by B. Yeah. I want to move 5 steps going to the right and 5 steps going to the left. 1, 2, 3, 4, 5. Then we also move 1, 2, 3, 4, 5 this side. So our ellipse becomes something like this. Okay. So I'm just learning how to use the tablet. That's why I'm struggling when writing. But 2 or 3 days from now, I'll get used. Okay. So we have something like this as our ellipse. Okay. We have our V1 there, a V2 there. Then we have the minor axis. We have M1, we have M2. Okay, so the time is almost up. I'm going to send another link so that we just finish ellipse and then we call it a day. All right.